Topic 7-5, referenced in our Holt book, Chapter 5, Section 8, page 356 through 362. There's a good application about making a bandana for a dog using the skills of these special right triangles. So check it out on page 357 if you'd like. This is more practice for these particular special right triangles. The 45, 45, 90 is derived from a square, cutting the diagonal like that one. And a 30, 60, 90 triangle is derived from cutting a equilateral triangle by its altitude and creating an example that would look like this one. So when you're wanting to find the lengths of a diagonals of different shapes, they may give in testing options just words. So you would have to be able to draw and understand some of the vocabulary to be able to just know it's not going to be given to you that you may be using a 45, 45, 90 or a 30, 60, 90. This being an example of a 45, 45, knowing that these two values are like the sides of a square. I could put a green here and a green there, and that would show that, with blue being the diagonal. So let's try that one to start with. The length of a diagonal of a square is an 8 square roots of 2. Find the lengths of one of the sides. So you would want to draw a square. Always drawing the picture is a good idea. So if I draw a square and I cut the diagonal goes from one corner vertex to the other. You now have created, it's not mentioned in the question, but you have created a 45, 45, 90. With the values across from our 45 being the same, just as shown in two green legs, with the blue being the hypotenuse. The hypotenuse is always a value of x square root of 2. Well, they gave us that this diagonal length was 8 square roots of 2. So if that's equal to 8 square roots of 2, we would need to solve for x. So 8 square root of 2 being equal to the value of x square root of 2. Solving for x, you want to divide by square root of 2 on both sides. This one makes it nice and simple. Simplified radical immediately because these would go away. So my side length, one of the side lengths is going to be 8. So each side length, this one, every single one of my sides would be equal to 8. Okay, here's one of the lengths of an equilateral triangle. That's more of an example of my snap legs looking like this. So if you were going to draw an equilateral triangle, I'm going to go ahead and draw it. Not sure this one. I think it's an equilateral. I flipped it around. Close enough. Alright, showing that all of these sides are equal. This one, and this whole side here would be an equilateral. If you cut the diagonal, the longest leg, that's always going to be opposite my 60-degree angle, which is a value of x square root of 3. We've learned in earlier units. Okay, so if this is x square root of 3, this small area here is a value of x, then this hypotenuse, I can draw my right angle, is always going to be 2 of those. Remember my example with this one showing that this purple, it would take 2 of those to make up the hypotenuse, which is this would be representative of my red snap leg. Okay, so they've given us that one of the side lengths is equal to 11. So 2x is equal to 11. So if 2x is equal to 11 and we divide by 2, probably we'll just go ahead and put this in decimal form. That's going to be 5.5, 5.5. Okay, so the altitude length is the 5.5 because that's my x. I just discovered what my x value is, this value right here. So 5.5 square roots of 3 would be this altitude. 5.5 square roots of 3 would be my answer. Because that's what they're asking for, the length of the altitude. Maybe it's a good idea to highlight what they're asking for in this one. Whereas this one, they were wanting just the length of one of the legs. Okay, the perpendicular of a square is 40 centimeters. So if we draw a square and we know that the perimeter is walking all the way around the outside is 40, that's going to make each of my legs 10. So if each of the legs are 10, and we draw our diagonal, they're wanting to know the length of the diagonal, so let's go ahead and highlight that. That's what they're looking for. Well, we know in previous lessons that the side opposite, our 45, 45, 90, is a value of x square root of 2. So if one of my legs is 10, that is my x, because that's equal to an x. So is this, and so is all the way around. So that all you're doing is substituting the 10 in for your x, so your answer for the diagonal is 10 square roots of 2. Final answer. Okay, there are some that are tricky like this in the way that they label it. We've always been using x as our variable, but if they're showing that both of these x's are exactly, x and y are the same, then this y is actually equal to that x. Let's just rename it. Your x and your y are the same, so that's just a value of x. This is where it's tricky. Some students forget that the side opposite our hypotenuse, if you want to just look at the formula for it, is a value of x square root of 2. So you're solving for x. So you're going to divide by square root of 2. Rationalizing the denominator would be to multiply by a power of 1. A power of 1 that will get rid of the radical is the square root of 2 over square root of 2. That's square root of 4, which in turn is 2. This is 6 times square root of 2. Don't multiply that and say square root of 12. It's not square root of 12. You have to keep your whole numbers and your radicals separate. However, this can be divided. 6 divided by 2 is 3. So 3 square roots of 2 is the answer for finding what the x value and the y, since those are equal to each other, they're both 3 square root of 2. So I guess if you want to highlight what we were looking for, it was both of those. So both x and y is equal to 3 square roots of 2. Okay, 2 more examples. These were drawn for you, and they still want to find values of y and x. Well, replacing y with what the value is across from a 90 in a special right triangle. If this is 30, we know this is 60, and this is 90. So this, again, is always, you can visualize it, 2 of my purples make up the red. So 2 of my x's would be what y is equal to. So replacing y with just a value of what it is as an x is helpful. 6 is always going to be equal to x square root of 3 because my long leg opposite a 60-degree angle has that value always. You can visualize that by thinking about this purple sliding, just turn it around, sliding up to here would be about that distance from here to, let me show it that way, that distance from about here to here. So there's always that value, whatever the x is, plus a square root of 3 proportionally more, no matter if this triangle was this size or proportionally bigger or smaller. Always the value is going to have an x square root of 3. Okay, so looking at that, we're going to first solve for x. So we only know the value of 6. So again, we got to remember our rationalizing a denominator because you're going to divide by the square root of 3 in order to get x by itself. But this needs to be rationalized by multiplying by a power of 1. Square root of 3 times square root of 3 is square root of 9, which is 3. 6 square roots of 3 is equal to x, but we're not finished because 6 divided by 3 is 2. So you've got 2 square roots of 3 is equal to my x. So if 2 square roots of 3 is x value, to solve for y, it's going to be 2 of those. So 2 of my x's, my x value was 2 square roots of 3. Here we're solving for our y because we're taking 2 times, substituting this in. If it helps showing that, that's the substitution of what we found out x to be. Box that, make it helpful. So that, again, you're only multiplying these two to get 4, keeping your radical in radical form. So y is equal to 4 square roots of 3. One more. We're trying to find the value of w, x, y, and z. They've given you 2. You now have this represented and one of these. So there's the diagonal of a square, and this is the diagonal of a, not diagonal, the altitude of a equilateral triangle. So if you know, again, we got to label things. It's best to label them first. So we got to label everything. So y is actually, this is where it gets tricky. Your y is the same thing as x. Because if this is a 45, that makes a square. So your y is really your x. That makes sense. And so your z is going to be 2 of your x's. And your w is equal to the x square root of 3. If it helps to separate this triangle out, go ahead and draw it separately. But this is a value of x, this line here is a value of x, and this is equal to x square root of 2. All we've done is label what we know, the values of our sides. And from here we can start. You have to start with the 45, 45, 90. Why? Because we need to find the value of x. Because if we find the value of x, all you're going to do is multiply by 2 and then plug in here. So start with this one over here. 45, 90. This right here would be a 45. So if 8 is equal to x square root of 2, divide by square root of 2. We've done enough of these. We're learning how to rationalize the denominator. We have to multiply by a power of 1, which is square root of 2. Square root of 2 times square root of 2 is square root of 4, which is 2. 8 square roots of 2 rationalizes to 4 square root of 2. Because you're just doing the division. 8 divided by 2 is 4. So if this is equal to my x, we now know that 4 square roots of 2 is my x. So if that's my x, we can start with either one if you want. You can say that our w, actually we'll do our, well, y. So y is also equal to 4 square roots of 2. Z is equal to 2, let's see, Z, where's Z? 2 of my x's. So that's 2 times 4 square roots of 2. So z is going to be equal to 8 square roots of 2. We've got z, we've got y, we have x. The only one left we need is w. And w is taking our x, which we know is 4 square roots of 2, and multiplying it by square root of 3. So that's going to be 4 square roots of 6. And that concludes Unit 7-5.